Hello, everyone.
Hello.
Welcome back to another week, another extremely exciting stream. We've got two very special people joining us from Polymaker today.
Yeah, we're going to cover a few interesting topics like metal manufacturing, not just by 3D printing metal, but we're going to see different use cases for one of their cool materials, which is PolyCast, which we've been using to um, enable automated 3D printing. But we're going to also see how other people have been using that material.
Without further ado, I'll introduce our guests. We've got Cody McKenzie and Nicolas Tokotu, both from Polymaker. Let me just bring them up on stream here. Thanks so much for joining us. And for those of you watching who don't know these guys, Nicholas has been working at Polymaker for 6 years now. And then we've also got Cody McKenzie. He's been working there for 2 years and he is a sales engineer.
Nicholas, why don't you tell us a little bit about sort of what this material is, how it's used in industry?
Yes, absolutely. So Polycast used the layer-free technology that came from our Polysmooth combined with the ash-free technology, which you can see on the screen now. We reduced the ash content from 0.5% down to 0.003, which is huge when it comes to investment metal investment casting.
So
So
what kind of problems would come up if there was ash left over inside it?
Yeah, so there's two main ones. The first one is from an aesthetic perspective. This ash will create some gaps in your surface, and you will end up with a very porous surface, very rough surface. And the second one is the mechanical properties. So this porous surface is actually also within the inside that will really weaken the print. So that's the main part. Actually, there's one of the video on YouTube that is exactly comparing regular PLA, and the benchy came out very rough with regular PLA only because of the ash, and the polycast came out very smooth.
Mm-hmm. And so, just to give people a taste of the way we ended up using Polycast, which is, it was definitely not its intended purpose, but I had been experimenting with metal filaments, metal, like sinterable metal filaments. The stuff we used was the 316L that BASF sells, but I know there are a couple other companies that sell this, and it's essentially a filament that by weight is like 80 or 90% metal powder, which you can print through a normal extrusion system on an FDM machine. In our case, we were testing it with, Ender, Prusa, and Ultimaker. But the problem with that material that a lot of people find is very difficult to get to adhere consistently. And we were interested in the idea of being able to produce these green metal parts on our Quinley automation system because lost wax casting or the type of casting that you would do at extremely high volumes with something like polycast, you still have this process of investment casting. You still have this process of you have to print a part and then you lose that part in the casting process. Where we were kind of interested in shapes that don't really work with investment casting, things that are only 3D printable. So we were looking at this sinterable metal and or one of the big issues with this type of 3D printing are things like the adhesion, which I mentioned, but also support material. And something that drew me to Polycast was the fact that it's got this ash-free technology because the concept was if I could print some kind of helper that would get the metal to work with our automation out of this polycast, when I sinter it, it will disappear in the oven. The polycast works really well with the vapor automation. So the raft gets printed out of polycast, and then with a dual extrusion system like the Ultimaker, the metal filament gets printed right on top. So it's got this really cool property that when you sinter it, the raft will disappear, and that can be extended to things like support material and like support interfaces as well. It's also nice to be able to print supports out of the polycast because it's way less expensive than the metal. Like it's an order of magnitude less expensive than the metal filament, which means you don't have to have like 40% of your part be metal filament that then gets sacrificed later.
When I first talked to you guys, learned about your application, how you were using PolyCast, I mean, it's so simple that you're like, man, there's got to be more people out there that use it. But for me, this was the first time I've heard people using PolyCast in this way. For me, PolyCast was used working business to business. Our customers use PolyCast for investment casting. That's how they use it. And some customers may keep things, tight-lipped and kind of want to be quiet about how they use stuff. But this is the first time I've heard about people using PolyCast this way. So it's always neat to see people be creative, because that's essentially what 3D printing is all about, is being creative and finding a solution to a problem, whether it be your problem or a huge problem worldwide. It's just finding a solution to a problem, and that's what you guys did.
Yeah, so why don't you give us a bit of an overview of how, like, what kind of industrial use cases either PolyCast or just Polymaker materials are used, and how that influences the design of the material?
Yes. So you can see on the left, it's a very bulky design, right? Because it's very hard to CNC complex parts.
Mm-hmm.
And then you have three main parts: the top one, the cylinder one, and the one at the back. And then they went from this to a one-time part that is bolted on the actual motor. PolyCast is very good for big investment casting. So if you're talking about big parts, currently SLA is used a lot in rapid prototyping, but it's very hard to produce a big part out of SLA for multiple reasons. So that shows the advantage regarding using PolyCast. The other one was they are not producing an amount that would explain the investment to a mold in order to create all of this wax part. And the third one is, like we say, the complex geometry. In order to do this kind of parts, injection molding is hard/impossible.
Mm-hmm.
So that's one of the case study that shows a little bit the advantage of using PolyCast. So let's say we start the process with in mind the fact that you are going to print completely different part every time. So 3D printing, no problem. You can have an automatic system that just have a queue of G code, and then that will just print any part that you put on the queue. Oh, I just realized, is that why the name is 3DQ?
Yeah.
Is that because of the Q?
Yeah. Very creative.
Great. Very smart. So 3D print, and then the polishing process is the same. Mm-hmm. Whatever the shape of the part, it will be the same. Then you build your tree. Same, you can put different part on the tree, and then rinsing, burnout, ceramic dipping, metal casting, cleanup, and the precision CNC. So maybe the only part that may be affected is the precision CNC, because if you keep putting different part, then maybe you will have to change the way the CNC will clean your part. But I guess if you know exactly the order at which the part will come, then you can also kind of have a queue of G code for your CNC. So at the end of the day, you just unlock with your automation system. You just unlock a way to mass produce customized part.
That's the beauty of 3D printing, is the wide range of uses for it. And one of those, we have several large-scale production customers that use these, and most of them, not most of them, but a couple of them are using them for prosthetics. Maybe it's a cast. Maybe someone's broken their arm, a cast like that. We have several customers that are using them for pediatrics. So babies, when they're born, some of them have what they call like a flat head syndrome, where they lay on their head so much the back of their head starts becoming flat. So they'll print helmets. And as you can see, like not every child or baby is going to have the same size cranium. So they're able to customize that helmet to fit those children in special cases. And then, of course, automotives, that's a huge one. Using our material and printing electrical housings, mostly behind the dash sort of parts. Yeah, it's been endless, but those are the main parts for us.
We're coming up to the end here, and I'd just like to thank you guys again I think it's been a very, fruitful and interesting discussion. I'm super excited to see more of your products and especially the cardboard spools, but just to see new applications that your materials are able to do in industry and you know experimenting with the PolyCast, and now I'm gonna have to try smoothing it because I haven't done that before.
Yes, yeah. Thank you very much for having us, and I do think we'll have more to talk about. You know, we have a large part of our customer base that begins as maker with a 3D printer, trying around, and usually business idea come, and you can very easily go from your prototyping to manufacturing by keeping the same tools, and automation help them to make that step. Thank you again for having us.
Yeah, I'm really looking forward to see what new materials you guys are coming out with, and especially any sort of ways that you could use 3D printing to like supplement existing manufacturing.
Yeah, it's been a pretty dense hour and a half, so there's a lot of knowledge in this video. I think anyone you know that's into 3D printing, definitely share it with them because I think they'll learn a lot. And so yeah, thank you again, and we'll go to our outro.